Hello, hello. Hello, hello. We are streaming. Pretty cool. Right. So I want to just get the chat, and then we will get started on what the title is, which will be implementing Poker. I guess let's just go on YouTube. Studio.youtube. Let's go on Twitch. Where is it?
Wait, did you do a snowball fight?
Okay.
Okay, Lexi.
Do a producer, something like this. Content. Come on, where is? I just want to know. Where is? I swear I am live. Oh wait, actually I did something interesting for work. I was getting super distracted, so I decided to just block YouTube. That's quite funny. Oh, this might drop the stream though. Oh, we'll see what happens. I think it's okay. Is it okay? Oh yeah, so it is. Just restarted. Okay. Pop out chat, that's what I wanted. Let's go in here as well. Yeah. I want the pop out chats. That's it. Here. And here. Let's stack these. Let's pin them as well. I actually want to save these because I keep doing this. So let's save. How do I do this? So save to a session, and this is YouTube chat plus Twitch chat. And let's tile them. Okay. So here we are. On the left is YouTube, on the right is Twitch. If anyone wants to say something, you're more than welcome. If not, we are going to get started by reading a little bit. So boring stuff. But we're gonna be reading. You know what? No, let's get straight into coding, I'd say. So it's are we gonna be really creative here? Just call it poker. Yes, we are poker. Zig, is there a zig in it? Zig in it. Sure. What's root.zig? Actually, let's just delete all. .zig cache zig init dash exe. No. Initialize a zig package in the current directory. Let's go with that. Yeah, this looks legit. So let's also just make it tmux and git init the.git ignore, and we don't want .zig dash cache. I think it is. So if I go here, zig dash cache, yeah. Oh yeah, I forget the LSP does this weird thing where it like freezes. Nothing in chat. Okay. So if we have, okay, cool. This is all correct. Zig.zon. Interesting. Okay, let's delete this. Let's go into main, and we have this. Let's just delete inside. Okay, cool. We have very empty Zig project, and we're going to start by implementing the hands. Right. Let me actually just double check by implementing the hands. Right. Let me actually just double check.
Yep.
By
Sounds
inputting
good.
on
Okay.
hands. Right. Let me actually just double check.
Yep.
By
Sounds
inputting
good.
on
Okay.
hands. So, right. Let me actually
poker hands
just double
have-
check.
Yep.
By
Sounds good. Okay.
hands. No,
Regular cards.
Check
Let
it
me
out.
actually
Poker
have
hands
double
have
check.
back of. It's actually
By
James.
hands.
Nine
So-
regular cards.
Check
Let
it
me
out.
actually
Poker hands
double
have
check.
back
Even
of. It's
them
actually
by
James.
Amazon.
Nine
So-
regular cards.
Let me
Maybe
actually
poker
have
hands
double
have
check.
back
Even
of.
them
It's
by
actually James.
Amazon.
Nine
So-
regular cards.
As you know, playing cards
poker
is
hands
not
have
really
back
Even
of.
them
It's
by
actually James.
Amazon.
Nine
So-
regular cards.
Not really
As you know,
another
playing
value.
cards
poker
is
hands
not
have
really
back
Even
of.
them
It's
by
actually James.
Amazon.
Nine
So-
regular
and
cards.
Lawsuit really
As you
another
know,
value.
playing cards is not really
Even them by
It's actually
Amazon.
James.
Lawsuit
So-
really
and
another
you know,
value.
playing cards
Even
is
them
not
by
really
Amazon.
Even though
Lawsuit
playing
really
cards
another
is
value.
not
Even them by
really
Amazon.
Even though
Regular
That is terrible audio. Wow, that is quite the oopsie. So right, I see. Is that better? Is that better audio? I think I had the I had YouTube playing my stream at the same time, so it just caused some really strange things. Let me mute for a sec, and I'll mute for a second and see if the audio is good. Let me mute for a sec, and I'll mute for a second and see if the audio is good. Audio is good on my end, I think. No, it's good. Alright, yeah, thanks. I just had YouTube playing, so I guess it created this weird, like, you know, like feedback effect. I would talk and then the stream would talk and then the stream would talk what the stream was saying, so it just created like really strange things. Okay. Hopefully it's good now. I just should make sure that this is muted all the time. Muted. You know what? Actually, I don't need these two open. I have the chats popped out, so it's all good. Thanks for that, by the way. Shuffle. Struct. So we want a function which takes in self, which is a pointer to self, which is a pointer to the deck. expected, return expression, you return void. And we need a shuffle algorithm. Shuffle algorithm. Fisher, yeah, it's shuffle. Sure, that looks good. The modern version of the algorithm designed for computer use was introduced by someone, blah blah blah. Sorry. Okay, so to shuffle an array A to n elements, shuffle an array A to n elements, an equivalent version which shuffles the array in the opposite direction from lower index to higher. I mean, I don't think it really matters, to be honest. Yeah, so let me just paste this over here for a sec. Let's comment that. And so we need to, for shuffle algorithm, we are going to need to, j is a random integer. Okay, so for I, which is 00 dot self dot cards dot length minus 2, 1, I think. So it goes all the way from the beginning to the end. Yep. Yeah, it sounds super crowd like people chanting some stuff. Yeah, no problem. Yeah. Zig random numbers. Standard. Oh, it's a standard library. So standard.rand.int. Okay. .int range at most. It wants between I, so I is 0. At most. Wait, what's the one there? Nothing. And at most, we want a usize. At least 0, at most. So, less than n. So we want at most self.cards.length minus 1. Const random index. And we want to go temp is equal to self.cards at random index equals this. Or actually at I. And now we go self.cards at I is equal to self.cards at the random index. And then self.cards at the random index is equal to temp. There we go. Do you compile? You do. So const new deck equals this. New deck.shuffle, and then we go return new deck. Const shuffled deck equals generate. No, not generate. Generate deck. Let's do const print equals standard.debug.print. Print the slice. Oh, actually, let's do any shuffle deck.cards. What for generate? What is this? Expected type to cards found error. Card deck. Error. Can I not do a try? Catch. Unreachable. Unreachable. Catch. Unreachable. Like this? No. Catch errors. Yeah, so we have this. We have statements. And we can just say catch. And just go unreachable maybe. And now, hopefully, default deck. Yeah, default deck no longer contains an error. Self. I think it's self.start.cards, right? That's how we get around that problem. Oh, it needs to be var down here. Why am I doing that? Expect for almost 1 3. For int at most, so once random. What? Standard dot rand dot standard dot random? Okay. So so it's like a random engine. Okay. No, okay. Why are you doing this? Sig random numbers. Oh, do I need like this? We go rand dot int at most. Still nothing. Standard dot crypto dot this guy. Oh, it found 4. Wait, okay, so we want the random, then we want comp time. At least at most. Actually, I have no idea what it's yapping about, to be honest. So you don't want this? I guess not. Okay. Okay, so let's see. So we have actually let's add a function called, so that's the shuffle done. Let's add another thing called print that takes in self deck. I think it takes in a pointer, doesn't return anything. For self dot cards card print well, let's just say it prints any for now, and let's do card. Print underscore deck. There you go. Shuffle deck dot print underscore deck. There we go. Then we get nice break lines. So you want no pointer. There we go. So we start off with the King of Diamonds, then the 3 of Hearts, Diamonds, yes. So it's all nice and shuffled. Anything in chat? Nothing in chat. What was Restream saying? So we have 2 on YouTube, 1 on Twitch. The Twitch one might be mine. Okay. Okay. We've shuffled. I think that's good so far. So far, so good. We can have. We should also have like delt index, which is a U size. We have shuffle, we have print, we have our function deal, which is going to take in pointer to deck, and it's going to return a card. So that's just going to go self dot. So it's going to go const card equals self dot card self dot delt index self dot delt dot index plus or equal 1, and let's return the card. So we can then go card. Let's go. const card 1 equals shuffle deck dot deal 2, 3, 4. Let's print card 1 like this. Same thing here. Like this. Let's see. So deal. Okay, so you have to be a var. Missing struct field delt default. Okay. Oh yeah. Dot. That's 0. Okay. Okay. So we start off by dealing the 9 of spades, the jack of spades, the king of hearts, and the 9 of diamonds. Cool. Cool. That's all good. Now that we have a deck, we could actually generally play some poker already. We could deal cards, but we don't have a solver, so it wouldn't be much use yet. But we can represent cards. We have a deck. This is a good place for a first commit. Oh, we don't want to poker the executable. We don't want to commit that. We do want this. We want this. Okay, feet. Deck. Data structures to represent deck of cards. Okay. Cool. This is nice. So far so good. What we could then do is actually get onto what I wanted to do it in the first place, which is the poker hand evaluator. So, for those who don't know, let's go and do a little bit of demonstration. That is horrific. That is also not good. Right. So in poker, you have. Actually, let me get my drawing tablet. This will be better. Right, drawing tablet acquired. Let's show some stuff. Just attaching it, guys. One sec. All right. Poker. So each player gets dealt in Texas Hold'em. Each player gets dealt 2 cards. So let's say one person has an ace of diamonds, and they have a deuce of also diamonds. They've been dealt these cards. Another player has a 4 of spades, something like that, and then they have the king of spades as well, and they have the king of clubs. Okay. In the board, in the middle of the board, the communal cards, there are 5 of them, 3 on the flop, 1 on the turn, and then 1 on the river. Let's say it comes ace of. So you can't have an ace of diamonds, right? Because there's already 1. Let's say ace of hearts, a 7, an 8. Let's say diamond. Let's not make a flush here either. So let's do 10 of spades. Sorry, club. That's a club. And a deuce of spades. Who wins? Or actually, let's make it a king. King of spades. The person who wins is who can collect the 5. Who can collect 5 cards and be the highest off. So this can come in different forms. So you can have these cards here. You can have just the 5 cards in the middle. Right? Or you can have this card and then this 3 and then this one. So it comes in a few number of combinations. So if you notice, there's 7 cards for potential player. And there are 5 possibilities. 7 combined 5. So if you remember Pascal's triangle, a little bit of maths, you end up with 7 C5, which is 21 possibilities. 21 possibilities, different types of cards for the 5. Who wins in this time? Well, the ace and the ace. Okay. Then it would follow by a king, the 10, and the 8. This is the hand that the player on the left has. So actually I take this card from their hand, 4 of these. And it goes ace, ace, king, 10, 8. And this is a pair. They've made a pair of aces. Player on the right, let's do it in some purple, like this. Player on the right also has a pair. Right, it's like a weaker pair, so they lose. They have a king, they take the king as well, they take the ace followed, then the 10, and then the 8. So their hand is going to be king, king, ace, 10, 8. They also have a pair, but this pair is weaker. So the problem comes from having, from taking these 5 cards and evaluating, all right, is the one on the left better or the one on the right better? Okay, so there's 2 ways of doing this. A dynamic programming way, which is what I'll be doing first. Dynamic programming is a technique when you generate your answers before answering the question. So in dynamic programming, if someone asks you, well, what are the Fibonacci numbers up to 100? You wouldn't try and calculate it on the fly. What you would do is you'd calculate all the Fibonacci numbers up to 100, and then you return the 100th number. And the other approach is you get asked the 100th number, and then you calculate the 100th number. Whereas in dynamic programming, you generate them all before. And this is useful. This is very useful because then you can just reuse solutions as well. Yeah, so that's what we're going to be doing. We are going to be generating all possibilities of 5 cards, which is 52 choose 5, which is, I think, 2 million. That's what the article, if I remember the article said. And we're going to rank them before the program even starts so that we have them saved. And once we have them saved, we can just load it into memory. It isn't that much memory, I think. And then we're good. And then we can just compare the cards in the middle and the cards the player has, the cards in the center, and we can see who wins. Okay, let's give that a go. Beforehand, we're going to read the article, see how that guy did it. But, you know. Anything in chat? Nothing. Okay, so let's do some reading. First off, any person who studied combinations, combinatorics, will know that there are C52.5 or 2.5 million possible unique poker hands. I realize that even though there are nearly 2.6 million unique hands, many of these hands actually have the same poker hand value. It's true. In other words, somebody holding Ace Jack 942 flush in spades has exactly the same value hand as somebody with Ace Jack 942 flush in clubs. Even though both hands are unique, they still hold the identical value and therefore would be a tie in poker games. True, even though that's impossible. You can't have 2 flushes on the board. 2 different suited flushes, but it's a good example. Here's another way to look at it. Suppose you were able to round up 2.6 million of your friends in a football field and gave each of them a unique poker hand to hold. You then yell in a loud voice, asking everyone to compare their hands with everyone else's hands. This will take some time, of course. Anyways, once they are done, you ask the person holding the best hand to step forward. Of course, 4 people will step forward, each holding a royal flush in each of the 4 suits. They're all tied for the best hand. That's correct. You group these people together, tie a rope around them, label them the rank 1, and ask them to leave the field. Now you do the same. Okay. So his approach is grouping hands into suited and non-suited hands. So when you have 5 of the same suit, you have a flush in poker. And I think flushes are what make the solvers difficult. If you didn't have flushes, then it would be quite straightforward. But because the flushes come into it, the suits come into it, it becomes weird. So, as you said, you have 4 royal flushes for each of the 4 suits, and you have quite a few straight flushes. but they really you only really care about whether they're suited or not. Okay. The next 8 queries would be, what is this? Instead of royal flushes, you have 3. What is this? This time, 4 more people come through, each holding a king high straight flush. Hold them together, level them 2, score them out of the field. 4 people holding queen high straight flushes, jack high straight flushes, 10 high straight flushes, 9 high straight flushes, 8 blah blah blah. The 11th time, then you have 4 aces with a king kicker, 4 aces with a queen kicker, blah blah blah, 4 deuces with the 4 kicker, tray. Interesting. The next query would be full houses, aces over kings, aces over queens, deuces over 4, deuces over trees. Okay. Note that by using combinatorics, we can verify these totals, assuming you have a full house of aces over kings. There are 3 possible ways to select 3 aces out of a possible 4, and 2 possible ways to choose 2 kings out of the 4 possible. 24 combinations of such hands, yeah. For the next query, we got a whopping 10, 20 people step forward. Ace high straights, yeah. There's a lot of ace high straights. Yep. So, yeah, here's the table. So, a straight flush has 40 unique and 10 distinct. 10 distinct is in 10 if you ignore the suit, I think. Yeah, so basically you have a lot of hands. Poker. Once I determined that there were only 7,460 distinct values of poker hands, I needed a way to quickly transform each of the 2.6 million unique 5-card poker hands into its actual value. To complicate matters, the algorithm needed to be order independent in the same order as if I pass. So blah blah blah. I'll change the order of the cards in my fashion. It must still return the value. Mixing up the 5 cards does not change the overall value of the hand. At first, I thought that I could always simply sort the hand first before passing it to evaluator, but sorting takes time, and I didn't want any waste CPU cycles. This is a hardcore program, so you can tell this guy did some embedding like C in the 70s or something when you had like 2 bits of memory. Like really hardcore stuff. Okay, after a lot of thought, I had a brainstorm to use prime numbers. I'd assign a prime number to each of them. Oh, this is really clever. Yeah, this is super clever. The beauty of the system is that if you multiply the prime value of the rank to each card in your hand, you get a unique product. Yeah, of course you do. Yep. So use this bit scheme where each card is type integer and therefore 4 bytes long. This is actually clever. I might actually change my entire thing to do this because I like this more than my enums thing. In a way, I like it more. Yeah, I think I do like it more actually. Okay, so you have prime number of rank, followed by some null bits. And then R, which is the rank of the card. Oh, the prime number. Okay, prime number of rank. The actual rank. CDHS suit of card. Bit turned on based on suit of card. Okay. Oh, yeah. Got it. Yeah, clubs, diamonds, hearts, spades. Bit turned on depending on rank of card. Okay. Now for my evaluator function, I would pass in 5 integers, each representing one of the 5 cards in the hand to evaluate. We will label these C1 through C5. We check to see if all the suits are the same. If so, then we have either a flush or a straight flush. The quickest way to calculate this is by evaluating this. Bitwise and, yeah, not, okay. First I do another bitwise OR of all 5 cards, nice. Bit shift value 16 to the right. Interesting. Note that if we have a flush, then all 5 cards ranks are guaranteed to be unique. Yep. We should have exactly 5 bits. Yeah. This is cool. This is very, very cool. Okay, again, these are bitwise, and the resulting values will range from the small to the very large. The smallest value is obtained if you hold the hand 2, 2, 2, 2, 3, 4 deuces out with a tray kicker. Multiplying its prime values yields number 48. Largest value comes with holding ace, 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 king. Doing the maths, we get 104 million. These numbers are way too large to use a lookup table, so we must find some other method to convert these values to their proper distinct hand value. Since there are only 4,888 remaining hand values, I decided to use binary search as fast and complexity of O log n. Actually, I mean, I don't really care. I could just use a hash map. Oh, and there's this here. Instead of binary search for those 4,888 hand values, he says he obtained a speed factor of 2.7x. Not too shabby, anyways. You can read more about it there. Okay, so the point is we can represent cards in a specific way, such that you can use binary operations to figure out what you have. So as they set up here, we would label them. If we have either a flush or a straight flush or a royal flush, the quickest way to calculate this is by evaluating C1, C2, C3, C4, C5. So the suit of the cards. Where is C? Or card 1. Oh, and then F000. F000 gives you, so just basically this here, he wants this. If they are all the same. Okay, yeah, if they're all the same, you have a flush. If the above expression yields a value of 0, then we don't have a flush. If it is a non-zero value, then we do. Assuming we have a flush, I need a fast way to calculate the actual hand's value that you convert to a value 127,462. Table lookups are one of the fastest ways to generate values with Linux, so I use the following coding technique. First, I do another bitwise OR of all 5 cards, then I do a bit shifting that value 16 bits to the right. So, we do C1, C2, C3, C4, C5, we OR them, and we shift to the right 16 times. So if we do have a flush, we're assuming we do have a flush. Bit shifted to the right. Wait, I don't get this. What's going on? Assuming we have a flush, I need a fast way to calculate the actual hand value, converting it from the value 127,462. Table lookups are one of the fast ways to generate values based on index keys. First, I do another bitwise OR of all 5 cards, then shift the values to the right. Note that if we have a flush, then all 5 cards ranks are guaranteed to be unique. Okay, we're shifting 16. So, okay, so we have these here. We have this left, which are the bits turned on depending on the rank of the card. And if we are ORing them, assuming we have a flush, they are unique. Yeah, they are unique, so you're going to get the actual hand strength. Okay, I understand now. Note that if we're flushed, yeah, they're all unique. We should have exactly 5 bits set. The smallest bit pattern would be 0x0001f, decimal 31, because this would be a 2, 3, no. Ace? No, you value the ace 12, so 2, 3, 4, 5, 6. Create a lookup containing this many arrays and then populate it with the correct hand value. Let's call this array flushes. If you have flushes, you should have 9 in distinct values. 6 high flush. There's another example. Let's say you are holding 6 high flush. 6 high straight flush. Yeah, okay. There's another example. Let's say you are holding ace, king, queen, jack, 9. Not straight. This bit pattern would be that. Okay, but now how is he calculating the strength of the cards, you know? I check the values of flush 31. You should find value 9 because 9 is the distinct means. Okay. If we should determine that we do not have a flush or straight flush hand, Move on to tackle straight and high card hands. So if you do have a flush, you can have a royal flush and a straight flush. Those are the top two cards in two hands in poker, and also you have the regular flushes. But is he populating these beforehand? He's actually like holding them. He's actually numbering them. You think? That's a lot of work. Okay. What happens if we don't have a flush or straight flush? We move on to tackle straight and high card hands. Again, we use a lookup table for speed. We create another array which is called unique 5. We use the same index Q as the index, this new array. Look, I really like this, I think. I really like this pattern. There's a lot of different arrays going on here. Let's read on, let's let them cook. We use the same index Q as the index into the new array. If the value found there is 0, then we do not have a straight or high card hand. If it is non-zero, then it holds the actual hand's distinct value. For example, king high straight has a bit pattern of 0x, 0f8, 0, or decimal 3968. This means that unique 5 should hold. Okay, yeah, so the unique. Alright, understand why. Okay, understand what's going on. The absolute worst hand in poker, 7, 5, 4, 3, 2 unsuited. 7, 5, 4, 3, well, it's a straight, it's not the worst hand. What? The absolutely worst hand of poker, 7. Oh, no, it is, yes. Because there's no 6, whoops. With just 2 easy calculations and 2 quick lookups, we have eliminated 2, 6, 2, 5, 7, 4 out of all those. That's little over the third of hands. Let's quick check the prime numbers. We take each card, extract its prime number, and then multiply all together. Okay, now we do this prime number thing. The resulting values will range from small to very large. Multiplying its prime factors, but the largest comes with holding this. Doing the maths, we get this. Since there are 1,800 unique. Wait, what is this? These numbers are way too large for lookup table, so use distinct hands. Decided to use maths fast with the complexity. I took the remaining 4,888 hands, calculated its prime multiplication value for each, placed them in an array, and then sorted. When I need to find distinct hand value after all previous effort fails, I'll do a binary search which returns index. Wait, really? That actually gives you hand strength? So we remove... What? I don't understand, bro. I'm so confused. So you remove flushes, all flushes. Then you remove straights and uniques, so like ace high and stuff, ace high and king high, whatever, all those types of cards. Cool. And then what? Then you you're left with what? So you've done royal flush, you've done straight flush, you don't have 4 of a kind, you don't have the full house, you've got rid of flush straight, you need 3 of a kinds left. Yeah. I'm still confused why these would yield the largest values and stuff. Kind of confused. Actually, let's have a look at this. Let's have a look at this SVN. Oh no, this just looks like some random thing. All 5, let's see. Not you. Oh, so you like compute them beforehand. Okay, yeah. Oh, the permutations there, and what is this big one here? These are the hash adjusted unique 5. This is a table lookup for all non-flushes. And what do we have here? The flushes. Okay. Okay, and he has this text file here. The poker hand on the right. So it's a table. It's a little table. 1, 2, 3, 4. Hmm. Apocalypse.c. Do. Hmm. Returns the hand rank of these. Okay. I'm still like confused though by how perfect hash lookup. This is interesting. This is this little line of code. It's really interesting. Static unsigned short eval 5 cards. Takes them, checks for flushes. Otherwise we're returning flushes. This checks for straights and high cards. This forms a perfect hash lookup for remaining hands. So this is cool. This is very cool. The thing I'm struggling to understand is how is he ranking them before? How are you actually ranking the hands values? Does that just come from the maths, like from doing all this? Like, would that actually just work out? So let's see, for example, like let's look at this code. So we eval 7 hand, which does blah blah, eval 5 hand. Eval 5 hand takes this is crazy. This is like such C programming behavior. Because it's an array, but it takes it in as an int. Like, it's so funny. Here we go, eval 5 cards. Q. Should we initialize short S? This checks for flush and straight flush, otherwise, and then it returns flushes. Let's look for flushes. Oh, flushes is in the header file, isn't it? I think it is. Well, not maybe not this header file. The arrays dot header file. Yeah. Both flush and straight flushes entries contain a 0, mean that combinations is not possible with a 5 card hand. Yeah. And then all the strength there, yeah. So if we scroll down, we will get rank 1, that's a royal flush. So he's actually gone and, yeah, so he's taken this text file here. And generated it. Suited, unsuited. Okay. This is a big thing because I want to do this part myself. I think that would be interesting to do. So what we're going to do is we're going to generate. We can generate all the cards, like all the different possibilities, right? Starting with the royal flush, going on to the straight flush. Then we have the 4 of a kinds, degenerate. Great, interesting, so interesting. these are all just nice and sorted as well. Yeah, it's so cool. I think the strat. Hear me out. What is the strat? I don't know what the strat is. Chat, I don't know the strat. The strat is to rank them beforehand. The strat is to copy this file. Guys, that's the strat. The strat is to copy this file, because how did he do it? How did he... You can sit down and do this. Like, you can write the raw flush, and you can write the straight flush. You can do the 4 of a kinds stuff. But, like, that's just effort. Yeah, I think I will actually just use this here. I think that's a problem for another day, though. Gonna finish the stream, wrap up. How long has it been? Hour and 15. Not much. Most of that was just weird chanting. But yeah, guys, thank you so much for tuning in.